The first thing we must do is to link the component parts together. First link the bolts to the conrod, then link the gudgeon pin to the piston head, and finally link the conrod to the piston. We must now select the inverse kinematics icon and then the hierarchy icon. In the roll down menus, first select the inverse kinematics button and then open the rotational joints menu. The first thing we can see is that we can select whether we have the X, Y or Z axis active. If we deactivate all axis radio buttons, we can see that if we try to rotate our conrod, nothing will happen. If we now check the X-axis radio button and then the rotate our conrod, we see that it will rotate where the conrod meets the piston. If we now select the limited option and then rotate our model again, you will see nothing will happen. This is because the from to values are set to 0. If we adjust the from parameter, we can see that as we change the value, our conrod rotates relative to that value. If we now set the to parameter as a negative value, we will see the conrod rotates in the opposite direction. What we have actually done is tell the conrod that it can only rotate between these two parameters. Clicking on the words from and to will allow you to view the rotation extents. We can see that if we rotate our model, it will only rotate to the set limits. It will actually move the model up and down rather than try to rotate more. The ease option causes the joint to resist motion as it approaches the from and to limits. The spring back option is a force which is trying to bring the conrod back to its rest position, as if a spring is pulling it back. The spring tension option sets a value for the strength of the hypothetical string. The higher the value, the stronger the spring. The damping option simulates its friction between the moving parts over their whole range. Again, the higher the value, the greater the friction or inertia force.